Hi grade 11s and welcome. In this video we will be covering topics in trigonometric identities, slopes of parallel and perpendicular lines, circles in the coordinate plane, volumes of cylinders and prisms, spheres, surface area and volumes. These are the 5 topics, and this is your review paper that was sent to you. So basically in this video we will be covering all these approximately about 24 questions, and so let's get straight into this because this is your preparation for the final examination. So going over just briefly going over question 1 and 2, let's see what are some of the formulas or topics that you've got to revise. So first one, cot theta sine theta. We know that cot is a reciprocal of tan, or you can say cot is cos over sine. If you're looking at part B, that's more into reducing angles and simplifying using the cast diagram. Now many of you guys are confused with the cast diagram, so let me just derive that for you, and then we can solve question 1. And obviously question 2 is more into like special angles. Remember, you have 5 special angles, which is 0, 30, 45, 60 and 90. Those are the special angles where a calculator is not required to solve these types of questions. So if it's a written question, you've got to do the work in detail. So let's go over some basic trigonometry that you need to know. In other words, trigonometric formulas and stuff that we can derive, and some trigonometric identities. So looking at question 1, I'm not going to start question 1 because just a brief overview. So question 1, let us look at some of the identities that we have, right? Identities, trig identities basically. Let's look at some trig identities. If I draw a triangle, basic general triangle, and just try to derive them, well, I'll put numbers here, I don't want to put it in general. So if I just put 3, 4, and this is the angle theta, we can see directly opposite that is 4, so that's the opposite. This is the adjacent, and the hypotenuse will be 5 because using Pythagoras you are going to say square root of 4 squared plus 3 squared, so you'll do something like this. So what you will be doing is basically the square root of, you'll be typing the square root of 4 squared plus 3 squared. Because we are finding the longest side, we have to square and add, so what we get is 5. So by Pythagoras we're getting this to be 5, and remember the hypotenuse cannot change with reference to theta here or there. Now if we find the 6 trigonometric identities, remember the trigonometric ratios we are finding using SOHCAHTOA. So how we use this acronym is basically SO is opposite over hypotenuse, which is sine, cos is adjacent over hypotenuse, which is cos, and tan is opposite over adjacent. So that's what I'm doing here. Remember SOHCAHTOA, very important to remember. Alright, so, and now if you go backwards it will become cosec. If you go hypotenuse over adjacent it will become sec, and adjacent over opposite will become cot. So we'll do all. Sine theta, let's write sine theta here. What is sine theta? Sine theta is 4 over 5. Remember, you can also generalize this thing by writing x, y and r. So sine theta is 4 over 5. What is cosec theta? Cosec theta is 5 over 4. So just remove this, let's put this in the side. 5 over 4. And we also know cosec theta can also be written as a reciprocal of sine, so 1 over sine theta. That's the relationship between cosec and sine. Cosec theta is basically 1 over sine theta. Next one is cos theta. Cos theta is basically 3 over 5, right? And the reciprocal of cos is sec theta. Sec theta is 5 over 3, and that can be written as 1 over cos theta. The relationship between sec and cos. Remember, if you type 1 over cos theta on the calculator, you have to say 1 divided by 3 over 5. Okay, so 1 divided by 3 over 5, which is 5 over 3, as you can see the answer. And the last one is basically tan theta. Tan is opposite over adjacent, so 4 over 3. 4 over 3. And the reciprocal of tan is cot theta, which is 3 over 4, and that can be written as 1 divided by tan theta. Very important identity, very important trig ratios. There are 6 trigonometric ratios that you got to know: sine, cos, tan, cosec, sec, and cot. And knowing these as well, as no formulas will be provided. Now the next important thing to work out is we've worked out reciprocal ratios and trig ratios. Next thing is the relationships and identities. Example, what is sine theta divided by cos theta? If I have to use these ratios, so what is sine theta? Sine theta is 4 over 5. Right, now divided by, I'll write it like this, divided by cos theta, which is 3 over 5. And remember to reciprocal this and change the division into multiplication. So what we have is 4 over 5 times 5 over 3. As we can see now that the 5's cancel out, and the answer is 4 over 3. Now, which question to be asked is which of the ratios is 4 over 3 here? So if we're looking at 4 over 3, we have tan theta as 4 over 3. So what we can say is tan theta. Remember, 4 over 3 is also tan theta. So what we can say is tan theta is sine theta over cos theta. And if you're going to reciprocal this, you basically get cot theta. Cot theta is cos theta over sine theta. Next important identity that we're going to derive is we want to know what is sine squared theta plus cos squared theta. So what is sine squared? Sine is 4 over 5, right, squared, plus 3 over 5 squared, which is cos theta. Now when you write a square like this, it basically means you're squaring the entire cos theta part. It's just the way that trigonometric equations and trigonometric functions are written. Example, if I put a cube, it's like this. It's the same thing as saying cos theta all cubed. It's the same thing as writing cos cube theta. Right, let's take this out and continue with our derivation. Right, so we've got cos, yes, we're simplifying this. So what we have is 16 over 25 plus 9 over 25, and 16 plus 9 is 25 over 25, so that cancels out, the result is 1. So this implies sine square theta plus cos square theta is equal to 1. So two very important identities that comes out from here, these diagrams, is obviously tan theta is sine theta over cos theta. So we're going to block this off, that's important. And the next one is this sine squared plus cos squared is equal to 1. Very important to remember, especially for simplifying trig ratios with division and multiplication and stuff. Right, so this is sorted out. Next thing what we're going to derive is the cast diagram. These are all important preliminaries in order for you to answer question 1 and 2. So looking at the cast diagram, Right, so in the cast diagram, how do we derive the cast diagram? So I'm sure you've seen things like this, like you've seen, remember when we say we in the first quadrant, we in the theta angle, right? So the cast diagram, so what we say is if we are in the first quadrant, then we are either theta 360 degrees plus theta, and if you are using this vertical line, right, so if you're using the horizontal line, this is the 0 degree line or 360 line. Alright, so if you're somewhere around here, right, if you're somewhere around here, that's theta angle. If you go right around and come back to the same position, is 360 plus theta angle. Right, let's take that out. And similarly, if you are in the second quadrant, we are here, and then as you can see, that's theta, so this is 180 minus theta, because this is the 180 degree line. Okay, so let's take that out as well. So let's just say this is 180 degrees minus theta. Remember, yes, if this is 180 minus theta, then this will become 180 plus theta, because you're going forward. Just after 180 is 180 plus theta. Then don't use the 90 and the 270. Now if you go down, remember I've used 180 before and 180 after. I've used 360 right around, so basically I've used right around plus theta. So now I want to go 360 before. 360 before will be 360 degrees minus theta. So this is basically using the horizontal line, right, and getting these angles here as highlighted. Now if I use the vertical line and see what I get, if I go before, that's 90 degrees minus theta. If I go after, it's 90 degrees plus theta. If I go before 270 is 270 minus theta. If I go after 270, it's going to be 270 plus theta. So that's how you locate the quadrants. Now if I ask you where is 270 minus theta, you are going to be in the third quadrant. If I ask you where's, and remember this 90 and 270 follows the co-ratio rule, right? So it takes co-ratio. Example, sine becomes cos, cos becomes sine, tan becomes cot, and sec becomes cosec, right? So let me just circle these because that's the cast diagram here, right? That's what you've got to know, right? So we have this entire diagram, so we'll use it in the future. For now I just want to derive this diagram and explain to you how we get these angles and stuff, right? So you have no issues when you're writing your external exams and stuff, right? So let us derive this diagram, right? So let me just block it off. Perfect. I do have some examples here that we can do. So looking at quadrant 1, we want to find what is sine theta, cos theta, and tan theta. Not only that, remember also the reciprocals you can find. So let's put this here. Guys, if you understand all this, you can just skip the first part and go to straight to question 1, right? So this is the quadrant 1 diagram. As we see here, I drew basically a circle with a radius r, and I took a point on the circle and an angle which is in the first quadrant, right? This is an angle on the first quadrant. So this angle over here is called theta, right? That's a radius. If I drop a perpendicular from a point on the circle, which is x and y, obviously the vertical line will be y, vertical height, right? This is 90 degrees and this is x. The horizontal distance will be x. So now if I try to find sine theta, which is opposite of hypotenuse, which is y over r, if I try to find cos theta, which is x over r, and if I try to find tan theta, which will be y over x, what do we notice from these is that Sine theta is positive because y over r, everything is positive in the first quadrant, positive, right? Right, let's see what we can say. It is positive, positive, right? That's positive, that's positive, and that is positive. So what we can say is all positive in quadrant 1. Why we say all positive? Because remember, if you try to find cosec, the reciprocal ratios, cosec, sec, and cot, you just have to say r over y, r over x, and r over, this is incorrect, should be y over x, y over x. Yes, so cot over here will be x over y. That's the reason why we say all is positive. So as you can see in the cos diagram, that's the reason why I have a there, because all is positive. Now the thing about why we say this angle is theta or 360 plus theta, there is an explanation. The explanation is that, see, if I go right around theta, if I come back to the same point, I went an entire revolution, which is 360 degrees plus theta. Now remember, if this is the theta angle, what's the top angle there? The top angle there is 90 minus theta. See the top angle? So this angle on the top, see that red bullet is basically 90 degrees minus theta. Now if I try to find sine, cos, and tan from here, yes, this will be 90 minus theta, and if I try to find sine theta, cos, you can't say sine theta, you have to say cos sine of 90 degrees minus theta, which is in reference to that red angle there. Why is that angle 90 degrees minus theta? Because this is already 90 degrees, this is theta, then obviously this will be 90 minus theta, because you've used up 90 degrees in the triangle, you are only left with 90. So that angle plus that angle must be equal to 90. So the dotted angle is basically 90 degrees minus theta. Right, so sine of 90 degrees minus theta, now your SOHCAHTOA is going to change, is reference to the top angle. So opposite of our hypotenuse becomes x over r. Cos theta will become, let's see, what does cos theta become? Sorry, not cos theta, cos of 90 minus theta, right? Let me just write everything out. And the last one is tan of 90 degrees minus theta. So what does cos theta become using SOHCAHTOA? SOHCAHTOA. Right, what does cos of 90 degrees minus theta become? The reference to the top angle. So where's the adjacent? Adjacent is y over r, right? And where's the tan of 90 degrees minus theta? So you locate the angle first. 90 degrees minus theta is here, and it's going to be opposite over adjacent. Opposite is x over y. Right, if you try to find tan theta, just for confirmation, there's the theta angle here, is opposite over adjacent, so y over x is correct. Right, so what do you notice is that when you're using 90 degrees minus theta, which other ratio is exactly the same as x over r? See, 90 degrees minus theta, it follows a different rule. It does not remain the same trigonometric ratio. It becomes something else. See, this is x over r, 90 degrees minus theta. It will become cos theta. So sine of 90 degrees minus theta will take a co-ratio. That's what we mean by co-ratio. So I usually call it a vertical reduction. When you're reducing using 90 and 270, it's always taking a co-ratio. So remember, using 180 degrees, 360 degrees, trig ratio remains the same, right? Remains the same. Now when you are using, so I usually call it horizontal reduction, and 90 and 270 is on a vertical line. So over here it takes co-ratio. Using 90 degrees and 270 degrees, the trig ratio sign becomes cos and stuff, so that takes co-ratio. Right, so you either add a co or you remove a co. Example, tangent, tan becomes cotangent, the full word. So tan becomes cot, secant becomes cosecant, so that's the second one. So, and vice versa, obviously. So secant will become cosecant, in other words cosec, and cosec will reduce to cos. And the last one is basically you have three co-ratios: sine becoming cos, cos becoming sine, sec becoming cosec, and cosec becoming sec, cot becoming tan, and tan becoming cot. Only with 90 and 270. That's what we call a co-ratio. Now we've done this one. Let's go to the, so we can see we are developing the cast diagram where we said in the first in the first quadrant all is positive. So see, in the first quadrant you can either have 90 degrees minus theta, as I explained, or you can have 360 degrees plus theta going right around, or the theta angle itself. Let's look at the second quadrant. You'll understand this better. Okay, so if you're looking at the second quadrant, right, so here we have the second quadrant, and if you try to find all these, right, if you try to find sine theta, now this is the theta angle, right? So this is 180 minus theta. See this angle on the inside? We call it the reference angle, or 180 minus theta angle. That's the reason why in the second quadrant this angle is represented as 180 minus theta. So what you can call it the reference angle, right? Reference angle is basically 180 minus theta, right? And this top angle is 90 minus the reference angle. Okay, let's just call it 90 minus the reference angle. Now what is sine theta? Sine theta is basically, or you can say sine of 180 minus theta here. What is it? It's basically, we are in the second quadrant, and whenever you're drawing, whenever you have a diagram in the second quadrant, remember this is in this direction we go positive angle, right, touching the arm, touching the radius, and in this direction we go negative angle touching the radius. So anyways, let's take that out and solve what is sine theta, cos theta, and tan theta. Let me just explain how we got this negative x, y, and r. Remember, that's the radius of the circle. I have a point on the circle. If I go vertical distance down, that's y. And remember, from 0 to x, horizontal distance is x. Distance is x, but the value itself is negative x because it's on the left hand side of 0. On the number line, if you're counting, so you have positive side on the right and negative side on the left. So what is sine theta? SOHCAHTOA again, opposite over hypotenuse, that's y over r, negative x over r, and tan theta is y over negative x, so negative y over x. Remember the negative from the bottom and took it next to the division line. As we see in the second quadrant, we say sine is positive, cos is negative, and tan is negative. So what do we have a rule in the second quadrant? We say sine is positive. Sine n is co-ratio. Sine n is a reciprocal ratio, sorry, not the co-ratio. Sine and is a reciprocal ratio, is positive in the second quadrant. Okay, positive in quadrant 2. So as we see here, cast diagram, that's the reason why we have an S there, because only sine and cosec are positive. Over here obviously all is positive. Over here similarly we're going to derive for tan, where tan and is a reciprocal ratio, which is cot. Tan and is a reciprocal ratio, which is cot is positive. Cos and is reciprocal ratio, which is sec. They are positive in the third quadrant and in the fourth quadrant respectively. So what we have done here, we said sine is positive, as we can see, y over r, negative x over r, these are negatives, that's positive. So second quadrant is done. Now if you're looking at the 90 degrees, what we said, this is, Yes, obviously you are 90 degrees here, and if you're going in this direction, you're kind of like adding theta. So that's the reason why we call the top angle 90 degrees. Sorry, that's the reason why we call this angle 90 degrees plus theta, because we're looking at going forward in this direction, right? That's 90 degrees. We will do more of those in co-ratios. Next one, looking at the third quadrant. Now I hope you got the hang of this. Now in the third quadrant, what we have is right. So in the third quadrant, we have this is the theta angle, as I explained. You start from the right hand side, in other words the ground, on the x-axis, on the positive x-axis, and just touch the hypotenuse, in other words the radius of the circle. And if you're going towards the left, on the horizontal is negative x, and coming down is negative y. So sine theta will be negative y over r, cos theta will be negative x over r, and tan theta will be opposite over adjacent, which is negative y over x, negative x. So we have negative y over negative x, which is y over x. That's the reason why we say, and the reciprocal of this will also be positive. That's the reason why we say tan is positive, cos is negative, and sine is negative. So what we have in the fourth quadrant is tan is positive in the third quadrant, positive in quadrant 3. Now last diagram. Tan is positive in quadrant 3. So what is the quadrant 3 angle? Remember, this is the reference angle theta here, and we're going just over 180, alright? Or you can say you're going 270 minus theta using the vertical line, alright? So that's either 270 degrees minus theta or 180 degrees plus theta. 270 minus theta or 180 plus theta. That's the third quadrant. 180, that's supposed to be 270 minus theta, and this one here 270 minus theta, and this is 180 plus theta, the reference angle there. Third quadrant, yes. So tan is positive in quadrant 3. That's the reason why we have 180 plus theta using the horizontal line, and using the vertical line we're going backwards, so 270 minus theta. And the last one, of course, and that's how we derive the cos diagram. In quadrant 4, we know x is positive, y is negative, and radius never ever changes, always positive. Remember, this is a 90 degree there, and that's your reference angle, 360 minus theta. That's your reference angle, 360 minus theta. If you're going past 270, that's going to be 270 minus positive theta, right? And this angle is 270 plus theta. If you're going in, yes, and if you're going right around, yes, that angle we said was 360 minus theta, because we're in quadrant 4. So what's sine theta? Opposite over hypotenuse, negative y over r. Cos theta is x over r, and tan theta is negative y over x. So as we can see, tan is negative, cos is positive, and sine is negative. So only cos is positive. So what we say in the fourth quadrant, cos is positive in quadrant 4. And there you have it, because and that's how we derive the cos diagram. I hope you guys are understanding. Don't forget to leave comments in the comment section. Right, so this is our cast diagram. Now let us apply the cast diagram. So how do we apply the cast diagram? Examples before I start the first problem. So how do I apply the cast diagram? If I say using 180 and 360 degrees, and if I have to use 90 and 270 degrees. So if I use 180, 360, how do I apply it? So if I ask you what is sine of 180 plus theta, let us simplify this. How are we going to simplify this? Right, I will use 90 and 270 later. So using the cast diagram, we're going to locate the angle 180 plus theta first. So if I use a cast diagram, right, I know 180 degrees is here and I'm going in this direction, so I'm at 180. Now I'm in 180 plus theta. I just went plus theta, so I'm somewhere here in the third quadrant. In the third quadrant only tan is positive, so sine is negative, so that's done. And the trig ratio remains the same, so negative sine theta. Now similarly, if I had, let's do 90 and 270 as well, so you understand what we're doing. Remember, in the third quadrant we can also have an example like this. Example, what is tan of 270 minus theta? We are basically in the third quadrant, right? Now in the third quadrant, tan is positive. Let's take sine, for example. Let's leave the tan out because let's say sine. So what's the difference between 180 plus theta and 270 minus theta? The difference is this is the trig ratio remains the same, only the sign changes. Over here trig ratio takes co-ratio. So what's the co-ratio of sine? Now before we do that, let's look at the quadrant first. 270 minus theta, we are here 270, right? And minus theta is just going back. 270 minus theta. So when you go minus theta, you go backwards. If you say plus theta, then you go forward, right? And what's backward and forward? Basically this is going right, going backwards is clockwise, right? That's negative theta, and going forward is anti-clockwise, right? That's positive theta. So now we're just going back to from 270 line, we're just going one back. So we're in the third quadrant. Remember, this is in quadrant 3, third. So in the third quadrant, sine is negative, and sine changes to cos because of the 270, cos theta. So because it takes co-ratio, 90 and 270 co-ratio, okay? Co-ratio, and 180, 360 same ratio. Only the sign changes because of the quadrants, same ratio. I hope you guys are understanding. Let's look at the next problem. Example, if I take cos of 180 minus theta. 180 minus theta is, there's 180 here. Minus theta is in the second quadrant. So obviously we are in the second quadrant, right? In the second quadrant we have cos, which is negative, so it's basically negative cos theta. Now what's the difference between cos and what if you have cos of 90 degrees plus theta? Remember, this is also in the second quadrant. Now cos in the second quadrant is still negative, but now because of the 90 it takes a co-ratio, it becomes negative sine theta. Okay, I hope you guys are understanding. And now we can go to the review paper and start solving these problems because we've done enough. Let's look at this. So let's look at question 1a, simplify. Right, so when we're simplifying these problems, what is cot theta? As I explained before, cot theta is cos theta over sine theta, because we said it's a reciprocal ratio of tan. What was tan? Tan was sine over cos. See, tan is sine over cos. So what is cot? Cos over sine. Basically reciprocal the sine over cos. Alright, so we have times sine theta. We know that this here and this one here cancels out, and the final answer is cos theta. Looking at the second problem, nice problem with division and simplifying trig ratios. So we're going to do each one separately and then solve it and put it together. So if I simplify each one, let me just do it in the side here. Simplifying, what is sine of 180 minus theta? Sine of 180 minus theta is in the second quadrant, right? So in the second quadrant, remember we have cast diagram, right? In the second quadrant, remember 180 minus theta, we are here 180 minus theta, we end up in the second quadrant, and sine is positive there, so the answer is just sine theta. The trig ratio does not take a co-ratio because we have a 180. Then what is cos of 90 degrees minus theta? In the first quadrant, right, because 90 is here and minus theta. So in the first quadrant all is positive, but cos changes to sine because of co-ratio, so it becomes sine theta. And then we have minus 1 divided by, what is cos of negative theta? Which quadrant is this in? Now there's many ways of doing this. Cos of negative theta, remember this is a zero line. If I just go back, that's negative theta, that's in the fourth quadrant, right? This is in the fourth quadrant, and cos is positive in the fourth quadrant. So what's the answer? Positive cos theta. Now the problem here is we have sine squared theta minus 1 divided by cos theta. How can we simplify sine squared theta minus 1? Well, we have an identity which is sine squared theta plus cos squared theta is equal to 1. Now if you modify this identity, what is sine squared theta minus 1? So we're going to bring the 1 over and take the cos squared over, so that's negative cos squared theta is sine squared theta minus 1. We bring the 1 over, take the cos over. Now it's an equation, so you're allowed to take this, right, change sides. So this is negative cos squared theta divided by cos theta. Now remember we have cos squared on top divided by cos theta. One of them cancels out with one of them there. Final answer is negative cos theta. I hope you guys are understanding. Next problem. Next problem, we have another nice problem here, which is using, okay, in order to do this we need to know some special angles, basic special angles, which, and applying the trigonometric ratios. So let me just add special angles here as well, right, because we will end up with a problem if you continue, because question 2 has all special angle problems. So let's put another bullet point here, another bullet, right, and we're going to call this section special angles, right? Now easy way to remember special angles, there are 5 special angles. I'm not going to draw diagrams and stuff, we'll just use a table to solve special angle problems, right? So the way I do it is like this, right? So I have 5 special angles, so I will create 5 lines for that, and obviously 1 line for the heading. These are all my special angles. I'll put it in radians and in degrees, right? So I'll have 2 angles column. And just remember opposite, adjacent, hypotenuse, the order. Alright, and the order is opposite, adjacent, and hypotenuse. Opposite, adjacent, and we'll take a hypotenuse from here, right? Let's make this right. Problem solved. Right, so we said the first 2 lines are for the angles, right? So I'll put angles here: opposite, adjacent, and hypotenuse. So this is the angle in degrees and this is the angles in radians. So degree angles are 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. So how we construct the table here is we count from 0, 1, 2, 3, 4, and we take square root. So remember, take square root here, square root here. So square root of 0 is 0, square root of 1 is 1, so root 2 is root 2, root of 3 is root 3, okay? And root of 4 is 2. So 0, 1, 2, 3, 4, I took a square root. And go backwards and count up. 0, 1, 2, 3, 4. So same, 0, root 0 is 0, root 1 is 1, root 2 is root 2, root 3 is root 3, root 4 is 2. And the hypotenuse is just all 2's fixed. Alright, now 0 degrees in radians is basically 0 degrees in radians is 0, 30 degrees in radians is 180 divided by 6, so pi by 6. 45 degrees is pi by 4, 60 degrees is pi by 3, and 90 degrees is pi by 2. Remember, pi is 180. Now, how do we solve these problems? If I ask you what is sine 30 on the calculator, sine 30 is opposite over hypotenuse. Remember to use special angles with SOHCAHTOA, right? SOHCAHTOA. Now, using sine 30, we go to the 30 degrees is opposite over hypotenuse. We can see it's 1 over 2. That's our answer, right? So we'll put it here, 1 over 2. Same, if we type this on the calculator, let me just show you how to use the calculator, because you don't know, some of you forget how to, change from radians to degrees, degrees back to radians and stuff. So if you want to calculate it in normal mode, you just say shift and clear, and you say just clear all. You'll come back to default, which is the degree mode, right? And press AC, just follow the instruction. So if I say sine 30, right, the answer is half. That's correct. But now if I put sine of pi by 6, right, 30 degrees is pi by 6, right? So let me just make it clear that you need to have your calculator in D mode for using degrees, right? So this is in D mode, right? D mode, in other words, degree mode. Now sine pi by 6, try typing sine pi by 6 in the calculator. If I try typing sine shift pi by 6 in the calculator, obviously if it's in degree mode it's giving me a funny answer. But if I change the mode, shift mode radians, option number 4, see what answer I get? I get half, right? So we also get half here in radians mode. So remember, when you're using pi and stuff, make sure it's in radians. So this is what? R mode. This is also half. Make sure this is in R mode. Now if you want to switch back from radians to degree mode, you just say shift mode and change it back to degree, which is 3. And obviously it's not going to give you a half, because sine 30 will give you a half, sine 30 degrees. So in the next section, when I'm doing it, let me just work with degrees, because that's your, your general mode, your default mode. Right, so that's how we use the special angles. Remember this. Most of them you can do it on the calculator. See, like if I put sine 30 is half, and but if it's a written question, just try to draw this and solve. I know some of you guys are using triangles. That's perfectly fine. You can use the triangles to find the special angles. That's fine as well. Right, so let's look at the next problem, because now you know special angles. So number 1C, right? Alright, so from this example onwards, we're not going back and adding more, preliminaries. These are stuff that you needed to know already during your class lessons. So we will solve the paper from here going onwards. Now, tan of 180 minus theta is in the third quadrant, right? Is it in third? No, it's in the second quadrant, right? In the second quadrant, tan is negative, so negative tan theta. That's my answer. Cos of negative theta, we said that was in the fourth quadrant, that is just cos theta. Sine of 390. Now very important, when an angle is more than 360, we just take out a revolution, that will just become sine 30. So we're minusing 360 from here. We'll subtract 360 from here, and we will get sine 30, because 390 minus 360. What's the concept behind this? The concept behind this is, see, this is a 30-degree angle. Now, not only 30-degree angle, I can add right around, and I can say this angle is not 30, this angle is 30 degrees plus 360 degrees, which becomes 390. So basically, a point where the angle is, you can subtract a revolution or you can add a revolution, you can come back to the same point. Revolution basically means going right around the point. So you can go in the negative direction or positive direction. That's the reason why if the angle is more than 360, we basically take away a revolution. If the angle is less than 360, we add a revolution. Okay. So we have this result already. Now next one is cos 300. Now cos 300 is after 270, before 360, so it's in the fourth quadrant. So what's the angle? If that's in the fourth quadrant, that angle here, this angle right around, is basically 300, right? So the angle on the inside is 60, right? So we can write cos 300 as cos 60, okay? Or you can say cos 300, right, is equal to cos 360 minus 60, right? It's the same thing. 360 minus 60 is 300. And don't worry about the 360, that the cos diagram, you know, takes into account the 360, because that's to locate the quadrant. So cos in the, remember 360 180 is not you trying to add and subtract, is the location of the quadrant. The location of the quadrant is the fourth quadrant, and cos is positive in the fourth quadrant. So cos theta, this is like your theta now, so it's cos 60, right? And then we have sine theta remains the same, minus what's cos 450. So we are going to take away a revolution. You will get cos, we're going to take away 360 from here, and 450 minus 360 is cos 90. Now we're going to find these things on the calculator, all the special angles, or using the, obviously we worked out sine 30 before, using the table for special angles. So we have negative tan theta, which is negative sine theta over cos theta, times cos theta times sine 30 is half, right, divided by, now if you want to use a calculator, what you need to do is basically you need to get all the angles acute, right? Example, and it has to be a special angle. Example, sine 30, right? If I'm typing sine 30, it's going to be a half, and you know there are 5 special angles, 0, 30, 45, 60, 90. Right, so now let's see what's cos 60. Cos 60 is also half. Let's check if that is true. Cos of 60, remember I'm not using a calculator, I remember the diagram, you know, triangles in my head. So if you're using cos 60, you can go to the diagram. Alright, what is cos 60? Adjacent over hypotenuse, 1 over 2. So we have half, and we have sine theta here, right, minus what is cos of 90? If I go use the table for cos of 90, adjacent over hypotenuse, the answer is 0. Okay, so minus 0. So what do we have? Let's just verify. Cos of 90 was the answer. The answer is 0. Right. Now what happens is, remember minus 0 remains the same. Half and a half cancels out. Just a second. So as I was explaining, the half and the half cancels out. And remember, we can forget about the 0, because that's minus 0 already. Don't even need to write it there. We can see that also on the numerator, the cos theta and the cos theta cancels out, and what are we left with is negative sine theta over denominator, which is sine theta. Even those cancel out, so you could have cancelled it out there as well. And what we have, the answer is, everything cancels out. The answer is not 0, the answer is negative 1. I hope you understand, guys. Let's look at the next question. tan of x minus pi by 2. Now remember, tan of x minus pi by 2 is in radians mode, right? So you can go and convert this into degree mode and work with that. So what we have here is basically I'm asking you a question: where is tan of x minus 90 degrees? Because the angle is negative, we're going to put it into the cast diagram, right? So let's make it a positive angle. So we're going to throw a 360 there, or add a 360. As you can see, 360 minus 90 is tan 270, right? And we just left with tan 270 plus x. I hope you're understanding, guys. Right, so what we do now is 270 plus x is in the fourth quadrant, right? So we have 270. Did we locate the quadrant? We have 270 and plus x. Plus x, we just go up, right? So plus x. In other words, go in anti-clockwise direction. So tan in the fourth quadrant is negative. It takes a co-ratio. Why? Because we are using 270. So negative tan cot changes to cot x, right? Tan changes to cot. So because it takes a co-ratio, that's it. Where did the negative come from? The location of the quadrant. Basically that's where the positive and the negatives come from. You need to locate the quadrant and use the cast diagram to determine. Remember, because the angle 270 plus x was in the fourth quadrant, only cos is positive there, so tan is negative, right? Not only cos and its reciprocal is positive. In other words, cos and sec is positive, so tan and the other four ratios will be negative. Only cos and sec, right? Remember, cos and its reciprocal are positive. So obviously tan will be negative. 270 plus x is in the fourth quadrant. Because of the 270, tan becomes cot, takes a co-ratio. Next one. Remember, why I could have determined from the outset that this was a co-ratio problem, right? Because of the 90 co-ratio, right? Co-ratio or same ratio, that's it. See, like this one, same ratio, same ratio. What about this one here? Same ratio, co-ratio, right? It's either same ratio or co-ratio. Just determine the signs using quadrants. Next problem, E. Okay, so we are lucky here because we don't have any, co-ratios. We only have same ratios. So tan of negative x, which quadrant? Fourth quadrant. Why? Because we are going in the opposite direction, right? So that's negative x is in the fourth quadrant, going positive direction, positive x, right? In other words, anti-clockwise, and this is clockwise direction is negative. So tan of negative x, fourth quadrant, cos of negative x, fourth quadrant, 180 plus x, 180 is here, plus x in the third quadrant. So we kind of have everything. Cast diagram, right? Third quadrant. So let's go, this is third. Now tan of negative x is in the fourth quadrant and tan is negative, so the answer is just negative tan x. Cos of negative x is in the fourth quadrant and cos is positive, so cos x. Cot is in the third quadrant and is positive, so it's just cot x. Remember, we can't change the cot to tan because it's 180. Only 90 and 270 takes co-ratio, so it was third quadrant, same ratio, okay? Same ratio, either same ratio or co-ratio. Now remember, tan is sine over cos, so negative sine x over cos x. Let me represent multiplication by using dots. Cos x dot cot x is cos x over sine x. Now what I can see is some cancellation happening. Cos x cancels out, and also we have sine x and sine x cancelling out. So all we are left with is negative cos x as my final answer, right? I hope you're understanding, guys. Right, let's look at the next question, number 2. what is the exact value of sine 15? Now for these ones, these are all not special angles. So what are these? These are sum and difference formulas, right? So what we have is these things. Remember the sum formula. What is sine of a plus b, things like that? What is sine x plus y? Sine x plus y is sine x cos y plus cos x sine y. So how it works is start with sine, end with sine, and the sign remains the same. Okay, start with the sine, so sine x, end with the sine y, and in between obviously you got to fill, and the sign remains the same. So I can make this 2-in-1 formula, which is sine x plus y, sine x cos y plus cos x sine y. If I have a minus here, then all I'll do is I'll change this plus into a minus, so minus remains minus. That's the sine. Second one, what is cos x plus y? Cos x plus y is cos minus, so cos x cos y minus sine x sine y. Now these are basically compound angles or sum and difference formula. Now the one with the plus remains, it changes sign, so it's minus, and if you have a minus, that will become a plus. Right, so follow the red with the red and the blue signs with the blue signs. Right. Next one. If I have tan, you don't really need to know tan because you know tan is sine over cos. But anyways, let's just do the tan here. Tan of x plus y, right? Which is tan x plus tan y divided by 1 minus tan x tan y. Right, so the plus goes with the plus, and if I have a minus, it goes with the minus. Change all the signs and that becomes a plus. So if I ask you what is tan x minus y, you're going to say tan x minus tan y divided by 1 plus tan x tan y. And there's a nice one for cot as well, right? So cot x plus y. We don't really need you to learn tan and cot, because remember tan x plus y, you can just say sine x plus y over cos x plus y. I'll do it in the problems. Right, so cot x plus y, we have cot x plus y, which is, you can say is 1 over tan x plus y as well, but we have a better formula, which is, should be 1 cot x cot y. Should be cot x cot y minus 1 over cot y plus cot x. Right, now the plus goes with the plus at the bottom, right? So just see, I've reversed this, cot y plus cot x. So if you have a plus, that's a minus on top and a plus at the bottom. So if you have a minus, it needs to follow with the opposite signs, right? So that's going to become, the minus will become a plus, right? And the plus will become a minus. Yep, that's the formula. Remember, we still got to verify. You don't need, I don't expect you to learn all this, right? Just sine and cos is fine. From sine and cos we can derive tan and cot in problem solving, of course. Right, so now solving these, remember we only have 5 special angles. So what is the exact value of sine 15? Now using the 5 special angles, how are we going to get these things? How are we going to get sine 15 using the 5 special angles? So remember we have 0, 30, 45, 60 and 90. So we want to use these angles to get 15 degrees. So you can either say 60 minus 45, or you can say 45 minus 30. Let me just use 45 minus 30. So I know this is sine 45 degrees minus 30 degrees. And I know 45 degrees, please don't try to open this up like this. This here opens up as a difference formula. So it's basically start with sine right? And sine remains the same, and end with sine 30. So what goes in between? Cos 30, right? And cos 45. Okay, now we know sine 45, if we use the table for special angles, we get root 2 over 2. Or if I use a calculator, I'll get the same. Alright, so sine 45, see, I've got root 2 over 2. If you try cos 30, cos of 30, you'll get root 3 over 2 minus cos 45 is root 2 over 2, and sine 30 is half. That's a famous one, right? So now we know root 2 times root 3 is root 6 over 4. Subtract root 2 times, that's root 2 over 2 times 2, which is 4. And same denominator, we can just add the top, root 6 minus root 2 divided by 4. If we type sine 15 on the calculator, just for verification, remember, if the question is written, you've got to show all your working right until the last stage, and in that form. If it's multiple choice, just you know what to do, right? So sine 15 is, we're just verifying that the answer is correct. Sine 15 is basically root 6 minus root 2 all over 4. Right, so I do have that answer there. Make sure your calculator is in D mode, right? The D mode, degree mode. Let's look at the second question. Cos pi by 12. Now pi by 12 is basically doing 180 degrees divided by 12. So all I'm asking you for is in, let's work this answer in degrees rather. If you say 180 divided by 12, we can convert the pi into degrees. So 180 divided by 12, you should get 15. Right, so cos 15. What's cos 15? We'll use the same concept as before. That's going to become cos 45 minus 30. So the expansion for cos is cos 45, cos 30 plus sign changes. Only for sign, the sign remains the same. Right, and sine 45, sine 30. If you do cos 45, there's root 2 over 2. If you do cos 30, you can use a calculator for this. Cos 30 is root 3 over 2 plus sine 45 is root 2 over 2, and sine 30 is half. So if I multiply all this out, something similar to what we have done before, root 2 times root 3 is root 6. You can see you're getting the same LCD, lowest common denominator, which is 4. 2 times 2 is 4. You can just add them up, right, all over 4, instead of splitting them up and re-adding. So let's just verify if this answer is correct. But remember, we're going to use degrees here because let's just say that was the original question. Shift mode, change it into radians, not degrees. We're going to use radians 4, and we say cos pi by 12, shift pi over 12. Yep, syntax error, we'll get there. Make sure you close the parentheses properly. So root 6 plus root 2 all over 4. So we are getting exact answers. We don't want answers like these, right? Because this is like decimal values and stuff. You're going to round off. This is an exact answer. Now if I type 15 degrees here, okay, let's take this and put it there. We know we are getting that answer. For verification, this is just verifying your answer, right? And if you change your calculator into degree mode like this, let's put 15 degrees here. Remember, the modes are different, that's important. 15 degrees, see what answer you're getting. So you shift mode, go to degree 3 and press equals, then you get the right answer. Alright, that's the difference between the two modes, right? So that's degree mode, this is R mode, right? So this is, let me just make it bigger, that's R and that's D. Right, perfect. Let's move on. Cot pi by 12. Right, cot pi by 12. As I said, you can use the formula to get the answer. Otherwise, what I will do is I'll just use cos over sine. Right. So what I will use is, let's see. Cot pi by 12 is cot 15 degrees. Now to get 15 degrees, you gotta say cot 45 minus 30 degrees. Okay, and we said the expansion for cot was cot, right, cot 45 cot 30 plus 1 divided by cot y, right? That's cot y minus cot y, which is cot 30 minus cot 45. Now let's see the formula, right? Right, so we have the formula here for cot, right? It's the one with the minus, so it follows the one with the plus, minus at the bottom, right? So that's fine. What is cot of 45? Now cot of 45, we can use the table here. Cot is adjacent over opposite 45, root 2 over root 2, which is 1 basically. So the cot 45 is 1. Or you can just say, how do you type cot on the calculator? There is no cot, there's a reciprocal, so 1 over tan 45, that is cot. What's the answer? 1. Right, that answer is 1. What is cot 30? 1 over tan 30, right? That's square root of 3, and there's a plus 1 there, leave it as is, divided by, what is cot 30? Root 3. And what's cot 45? Minus 1. So what do we have altogether? We got root 3 plus 1 over root 3 minus 1. The calculator will not give you this answer because it will ask you to rationalize. So you will multiply by root 3, will multiply by the conjugate, root 3 plus 1 over root 3 plus 1. Right, so now root 3 times root 3 is 3. Root 3 times 1 is root 3. 1 times root 3 is root 3. So basically I'm just doing products, root 3 times that times this, because there's, remember, imaginary parentheses around this. Why? Because you are multiplying two terms with two terms. Now this here becomes difference of two squares, remember, because a squared minus b squared is basically a plus b into a minus b. That's what I have. I have a plus b into a minus b. So if you square the root 3, we forgot to do one more term here. 1 times 1 is 1, so plus 1. If you square the root 3, that's basically root 3 squared, right, minus 1 squared, right? That's your a, that's your b. Now if you simplify all this, you're getting 4 plus 2 root 3, and this is basically 3 minus 1, which is 2. Now if you divide everything by 2, divide by 2 on top, divide by 2 at the bottom, you should get the answers. Divide by 2, divide by 2. Whatever you do to the numerator, do the same to the denominator. So 4 divided by 2 is 2. 2 root 3 divided by 2 is square root of 3, and 2 divided by 2 is 1. So that's the answer, 2 plus root 3. Now how do we type this in the calculator? Cot pi by 12, easy. 1 divided by tan shift pi over 12, right? Because that's what cot is, 1 over 10. What's the calculator in D mode? No, I need it in radians measure, radians mode, right? So now I press equals 2 plus root 3. That's my answer. That's it. Perfect. Now remember guys, because there's so many formulas for tan and cot, there's no need to write, remember the formulas for tan and cot. So is there another way to solve this? Yes, there is. Remember, the original question was, so let's look at method 2 without remembering formulas for tan and cot. If you remember, it's better for you, but just remember sine and cos is important as well. So if I redo this question using cos over sine, will I get the same answer? Yes, we should. Right, so let's try that out. Right, so cot pi by 12 is equal to cos, remember this is 15 degrees, alright? So that is cos 15 over sine 15. Now what is 15 degrees? Cos of, we were always using 45 and 30. Remember we can also use 60 and 45. So cos 60 minus 45 divided by sine 60 minus 45. Now what's the expansion for cos? Cos, cos, sine, sine. Cos 60 cos 45 plus sine 60 sine 45 divided by sine. What's the expansion for sine? Sine start with sine, end with sine. Sine remains the same, right? And fill in the cos. Cos 60, no, cos 45 sine 60 cos 45, then cos 60 sine 45, right? We have everything. Cos of 60 is half, cos 45 is root 2 over 2, cos 45 root 2 over 2, plus sine 60 is root 3 over 2, sine 45 is root 2 over 2. Now divided by sine 60 is root 3 over 2, cos 45 is cos 45 is root 2 over 2, minus cos of 60 is half, sine 45 is root 2 over 2. Now we can see on the numerator we can take out, what can we take out as a common factor? We can take out quarter as a common factor. So if you take out quarter, remember why we're taking out quarter? Because you got 2 times 2 here, and yeah, so basically 2 times 2. If you take out quarter as a common factor, basically you took the entire denominator out, you left to square root of 2 here, plus I took out a quarter, 2 times 2, so you are left with the root 3 times root 2. Okay, if you're not understanding that, then we can just multiply by 4 on top and multiply by 4 at the denominator. It will be the same. So that's the root 6, right, divided by quarter. I'm going to take that out as well. Root 2 times root 3 is root 6, right, and quarter, so minus root 2. Okay, so as we see, quarter and quarter cancels out. Now to simplify the denominator, we're going to multiply by the conjugate, which is root 6 minus root 2 plus over root 6 plus root 2, because this is the conjugate. I added this part here because my denominator is root 6 minus root 2. Change the color. Alright, now let's multiply everything out. Root 2 times root 6 is basically root 12. Alright, root 2 times root 2 is 2. Root 6 times root 6 is plus 6. And root 6 times root 2 is plus root 12. Okay, because remember root a times root b is square root a times b. Just remember that. Let's block off this idea, right? Obviously it's longer because you don't remember the formula, so it's still worth it, you know. And the next one is a squared minus b squared, because minus, that's plus, conjugate, right? So 6 minus 2. Now I will simplify all this. Remember, square root of 12 we can write as 4 times 3, so 2 root 3. And let's check if that is right. What is square root of 12? That's 2 root 3. 2 root 3 plus 2 root 3 times 2, right? 2 root 3 times 2. There's a times 2 because it's root 12 plus root 12. Root 12 is already 2 root 3, so times 2, plus 8, right, and divided by 4. So I can take out 4 as a common, I can divide by 4 on top and divide by 4 at the bottom. So 2 times 2 is 4. 4 divided by 4 is square root of 3. 8 divided by 4 is 2. And 4 divided by 4 is 1. So what's my answer? 2 plus root 3. Did we get the same answer before? Yes, 2 plus root 3. Perfect. Or root 3 plus 2. Same thing. Alright, so we did get the answer. So I don't need to remember, formulas for sine and cos. I don't need to remember formulas for cot and tan. I can just use sine over cos or cos over sine respectively for tan and cot. Right, so continuing with these problems, let's look at tan 15. Alright, so because we did the harder one, I don't really think this will be difficult now. Tan 15. For practice, right? Tan 15 is equal to, let's use 45 and 30. Right, so tan is tan 45 minus tan 30 divided by 1 plus tan 45 tan 30. That's the formula. Right, and now I think that was the formula, right? Just verify. Obviously, once you work out the answer and you mess up the signs, you can always check up with the calculator. But if calculators are not allowed in your external exam, what are you going to do? Yep. So make sure you remember the formula, sine over cos, or where's my not special angles? Where's the angles I've shown you before this? Yeah, tan x minus y. Tan x minus tan y, 1 plus tan x tan y. So this formula is right. Now tan 45 is 1, right? Minus tan of 30, I think tan 30 is root 3. Tan 30. No, you can see because the calculator is in incorrect mode, so put it back to degree mode. Is basically root 3 over 3, right? And 1 plus tan 45 is 1 times tan 30 is root 3 over 3. So what we're going to do is multiply by 3 on top and multiply by 3 at the bottom, because it's you can see it's divided by 3. So 1 times 3 is 3. Root 3 over 3 times 3 is just negative root 3 divided by 1 times 3 is 3. Root 3 over 3 times 3 is root 3. Now what we can do is we can use a conjugate and simplify. So 3 minus root 3, 3 minus root 3, and now simplify. 3 times 3 is 9. 3 times negative root 3 is negative 3 root 3. Negative root 3 times 3 is negative 3 root 3. Negative 3 times negative 3 is positive 3. Negative root 3 times negative root 3, alright? Product of the last two. If you do this, just 9 is basically 9, because 3 times 3 is 9. 3 squared minus a squared minus b squared minus 3. Now we simplify. 9 plus 3 is 12 minus 6 root 3 divided by 6. I can see 6 is common everywhere, so divide by 6 on top and divide by 6 at the bottom. So 12 divided by 6 is 2, 6 divided by 6 is 1, right? So, and 6 divided by 6 is 1. So that's it, that's my answer, 2 minus root 3. Let's try tan 15 on the calculator and see if you get 2 minus root 3, right? Tan 15. Obviously you can't work out tan 15 directly on the calculator because it's not a special angle. You have to use special angles to derive tan 15 and stuff, right? So 2 minus root 3, which is correct. Or you can use sine over cos like this and continue. Next problem. We have cos of 75, easy, right? Cos of 75. Right, so how are we going to calculate cos 75 is like this. Cos 75 is using special angles. Cos of 45 degrees plus 30 degrees. So is cos minus sin. Cos 45 is root 2 over 2. Cos 30 is root 3 over 2 minus sin 45 is root 2 over 2. Sin 30 is half. So you remember same denominator, which is quarter, or which is 4. Denominator is 4, so I can just put 4 here. Root 3 times root 2 is root 6 minus root 2. You can verify the answer, cos 75 on the calculator, and see if you get the same thing. Cos 75 equals, yep, root 6 minus root 2 all over 4. I hope you guys are understanding. Right, next question. Tan 5 pi over 12. That just looks crazy. So what you need to do is just change the pi into degrees. Much better to work with, right? I'm sure you got used to degrees now. So we're going to change the pi into degree mode, right? So 5 times, obviously pi by 12 is 15 degrees. 15 times 5 is 75. So we're basically working with tan 75. You can check that out. 5 times 180 divided by 12 is 75, right? Now how do we write 75? Tan 45 plus 30. So what's this tan sum formula? Tan 45 plus tan 30 divided by 1 minus tan 45 tan 30. So it looks like you have to do a rationalization here as well. Tan 45 is 1. Tan 30 is root 3 over 3. What's tan 30? Tan 30, yep. Tan 30 is basically root 3 over 3. Yes. Right? Divided by 1 minus 1 times root 3 over 3. Now you need to multiply by 3 on top because we have a denominator, and multiply by 3 at the bottom because we have a denominator. Is going to cancel out. 1 times 3 is 3 plus root 3 divided by 1 times 3 is 3. Root 3 over 3 times 3 is negative 3 times. We need to multiply it by the conjugate, which is 3 plus root 3 divided by 3 plus root 3. Right, we did enough problems like this. If you open this up, you're going to get 9 plus 3 root 3 plus 3 root 3. Root 3 times root 3 is plus 3 divided by a squared minus b squared, 9 minus 3. Now 9 plus 3 is 12 plus 6 root 3 divided by 6. We're going to divide by 6 on top and divide by 6 at the bottom. 12 divided by 6 is 2, 6 divided by 6 is 1, and denominator is also 1. Right, so my final answer is 2 plus root 3. Let's check if this answer is correct using tan 5 pi over 12. So let's type tan 5 over 12 shift pi, change the mode to radians. Right, what's my answer? 2 plus root 3. Perfect. I hope you guys are understanding. Right, so now we have completed question 1 and question 2. A lot of trigonometry, which is basically important. Right, so this is radians. Why is radians? Because I'm using pi. If it was degrees, then change it into degrees. Obviously degrees will say degrees there. That's a symbol for degrees. Right, so we've completed number 1 and number 2. Let's move on to number 3. Alright, so these are some nice questions. Now what's the story about parallel lines, perpendicular lines? What's the relationship? So lines are parallel if the slopes are equal, right? So if m1 is equal to m2, then it's parallel lines. If it's perpendicular, then the product of the slope must be -1. m1 times m2 must be -1. Otherwise, it's neither. Right. So now let's look at these problems here and see if we can solve them. Other lines through the given points parallel, perpendicular, or neither. Other lines L1 and L2 passing through the given pairs of points parallel, perpendicular, or neither. So let's find slope. How do we find slope? Y2 minus y1 over x2 minus x1. That is the slope formula. So what's m1? There, 1 minus 2 divided by 3 minus 1. 1 minus 2 is -1 over 2, right? That's done. What's the second slope? Second slope is 0 minus minus 1, so 0 plus 1 divided by 2 minus 0. So what do we have? We have half, 1 over 2. So we can clearly see that m1 is not equal to m2, so it's not parallel. This is a symbol for parallel lines, the two slashes, and the symbol for perpendicular line is an upside down T, so it's not parallel. And m1 times m2 is not equal to -1. Can you see? The product of -half times half is -1/4. It's not equal to -1, so it's not perpendicular. So what's the final answer? Final answer is neither. It's neither parallel nor perpendicular. Second problem. Let's see what's up with this. So remember, a line can be either parallel or perpendicular or neither, right? You can't have a line, you can't have two lines which is parallel and perpendicular, right? It's either or. It's just one of them. So what's m1? The slope. m1 means slope of the first line. 1 minus 3 divided by 3 minus 0, which is -2/3, -2 over 3. Second slope is -5, -4 divided by -7 plus 1, because -7 minus -1, right? -7 plus 1. So what we have is -9 over -6. If you simplify this, you'll get 3 over 2. Perfect. So we can see m1 is not equal to m2, so it's not parallel, but it is perpendicular maybe. M1 times m2 is equal to -1, so it is perpendicular. How? -2/3 times 3 over 2 is equal to -1, so this is perpendicular. So what's the answer? The answer is lines L1 and L2 are perpendicular, right? You can multiply them out because you can clearly see -2/3 times 3 over 2. You can see the 3 and the 3 cancelling out, 2 and the 2 cancelling out, so the answer is -1. So these two lines are perpendicular. Very simple, right? Let's look at C. What's m1? So y2 minus y1 over x2 minus x1. -7 minus -1, so in other words +1. 5 minus 2, so we have -6 over 3, which is -2. And m2 is 2 minus 0 divided by -1 minus 0, so we're just getting -2. So we can see the slopes are equal, so lines are parallel. So m1 equals m2, so what it is? Parallel. So what's the answer? You can just write down parallel. L1 and L2. Lines L1 and L2 are parallel but not perpendicular. Let's look at D. Right, so as we see in D here, line slope m1, 0 minus 0, right? So 0 minus 0 divided by 2 minus 1. The answer is just 0 because you have 0 on the numerator. And m2 is -5 minus -5, so m plus 5 divided by -10, -5. so we have 0 as well. So m1 is equal to m2, so it is parallel. Now the problem with the thing about slope being 0, it means there is no slope. It's a horizontal line. What's the slope? Slope is basically when you go up, a slant line is a slope. So a horizontal line has no slope. So it's parallel because lines are horizontal. These are horizontal lines. Horizontal lines. Right, this line is also horizontal, this line. So it's basically something like this. See, the first line is 1 0 and 2 0. Where's 1 0 and 2 0? 1 0 and 2 0. So it's basically the x-axis. Line L1 is basically on the x-axis. There's 1 and 2. And the second line is 5 and minus 5. X value 5, y value minus 5 is here. So 5 and minus 5 is somewhere around here. And negative 10, so it's another horizontal line there, as you see, because it has the same y value, right? So these lines are parallel. Looking at E, let's look at E and calculate the slope and see what's happening. So what we have here is m1 7 minus 5 over negative 2 plus 2, negative 2 plus 2. Now what do we have? We have 2 over 0. Now 2 over 0 is undefined. Now when the slope is undefined, then we have a vertical line, right? And the next one is m2. Let's see, 13 minus 1 divided by 5 minus 5. So we got 12 over 0, again undefined slope, right? So we still have a vertical line. So don't say m1 equals m2, just say lines are vertical. L1 and L2 are vertical lines, right? So you can kind of like draw it. L2 is 5 1 5 13, so it's here, right? And L1 is, this is L2, L1 is here, negative 2 5, negative 2 7, the same x value, right? So these lines are vertical. Lines L1 and L2 are vertical lines, therefore they are parallel, right? Now remember, if you have one slope which is undefined and another slope which is 0, then those lines will become perpendicular. Example, if you have a horizontal line, if you have a vertical line, obviously it will be perpendicular. Very important, right? Moving on to the next question. Write two equations in slope-intercept form of the line that is parallel and perpendicular to the given equation and passes through the given point. So we basically need two equations. One equation is parallel, passing through the point, and the other equation is perpendicular. So if you are observing this equation here, remember the standard form is y equals mx plus b, right? Or y equals mx plus c. We can clearly see the slope is 3. So m is 3. So what's the slope of the parallel line? Parallel lines have equal slopes, 3. What's the slope of the perpendicular line? Remember, that's 3 over 1. So if you flip this, it's going to become 1 over 3 with a negative, with an opposite sign. So it's negative reciprocal, the perpendicular slope to the parallel line. Alright, parallel and perpendicular, that's a relationship. No, that's not the relationship. The relationship is from the original. So parallel lines have same slope, and this slope and this slope, what's the difference? The difference is that this is negative reciprocal, so the negative reciprocal times 3 is going to give you product of 3 and negative 1/3 will give you negative 1. Now we want to find the equation passing through this point here, right? Write two equations in slope-intercept form of the line that is parallel. There's a line which is parallel, the slope is there, and this is a point to be substituted, right? And perpendicular to the given equation and passes through the point. So you must write two different equations. So we're going to write y minus y1 equals m into x minus x1 and then solve them. Y minus y1 equals m into x minus x1. The m here is equal to 3 into x minus, what's x1? 4. Y minus, what's y1? 7. Same equation with different slope. Y minus 7 equals negative 1/3 into x minus 4. If we open this up, we're getting 3x minus 12 plus 7. So what did we do here? We opened this up and we transferred the 7 across. So it became positive 7. So now the equation is 3x minus 5 minus 12 plus 7. Next equation, negative 1/3 x, right? This is negative 1 over 3 plus this plus 4 over 3, and take the 7 across, so plus 7. So you're getting negative 1/3 x. Don't say 7 over 1. Say that's 21 over 3. So plus 25 over 3. You can add them up and see. Use the calculator, add them up, get plus 25 over 3. So the first equation is the equation of the parallel line passing through this point, parallel to this line passing through this point, and the second equation is the equation of the perpendicular line, perpendicular to the original equation and passing through this point 4 and 7. Next problem. If we try to take out the slope from here, we're getting slope 1 because the coefficient of x is 1. So m is equal to 1. So the equation of the parallel line is 1, the slope, and the slope of the perpendicular line is negative 1. So y minus y1, y minus 3 equals 1 into x minus minus 2, so plus 2. Y minus 3 equals negative 1 into x minus minus 2, so x plus 2. If we simplify this equation, thus y is equal to x plus 2 plus 3 is plus 5, and y is equal to negative x, that's negative 2 plus 3, positive 1. So that's perpendicular and this is parallel. Next one. C. Right, so as we see here in problem C, the slope is half. So the parallel slope will also be half because parallel lines have equal slopes, and the perpendicular slope will be, you've switched this around, you use negative reciprocal, so it becomes 2 over 1, so negative 2. So y minus y1, what's y1? Minus 5, so minus minus 5 become plus 5, half into x minus 4. So if you open this up and take the 5 over, you're going to get half x minus 2 minus 5. So final equation is half x minus 7. That's the equation of the parallel line. perpendicular line y plus 5 equals negative 2 into x minus 4. We're getting negative 2x plus 8 minus 5. So y perpendicular is negative 2x plus 8 minus 5 plus 3. So let's move on. I hope you're understanding, guys. Part D. So we have y plus 2x equals 4. Be careful here because we want to find the slope of this line. So we need to rewrite this equation in slope intercept form. So y equals negative 2x plus 4. That's the equation of, because you have to solve for y, right? So all the previous example had y equals, right? Y equals. The coefficient next to x is your slope. So what's the coefficient next to, what's the coefficient, the number? The number next to x is your slope. So slope is negative 2. So m parallel will be negative 2. M perpendicular will be half. So y minus y1, which is 2, equals negative 2 into x minus x1. Minus minus 1 is plus 1. Y minus 2 equals half into x plus 1. Yeah, so we have y minus 2 equals half into x plus 1. How did we get plus 1? Because minus x minus minus 1, right? So taking the 2 over, so we got half x plus half, right? Half x plus half plus 2, because we take the 2 over and open this up. Now we get half x, half plus 2 is plus 5 over 2. That's the perpendicular, and the parallel is y equals negative 2x, negative 2 plus 2. So just y parallel is negative 2x. Plus 2 minus 2 cancels out like this. Continuing with the next problem. Right, so what do we have in here? Ah, yes, even a better sum. So if we take this over and resolve for y, we're getting 7y equals negative 4x plus 3. So y equals negative 4 over 7x plus 3 over 7. So what we have here is our slope, which is negative 4 over 7. So the equation slope of the parallel lines is negative 4 over 7, and slope of the perpendicular line is 7 over 4. So if we solve this, y minus y1, which is y plus 7, equals negative 4 over 7 into x plus 4, and we have y plus 7 equals 7 over 4 into x plus 4. Perfect. So we got y equals negative 4 over 7x minus 16 over 7 minus 7. Now don't say minus 7. Minus 7 can be converted as negative 49 over 7. So minus 4 over 7x. Negative 16 over 7 minus 7, you should get negative 65 over 7. And y is equal to 7 over 4x. 7 over 4 times 4 is plus 7, and take the 7 over minus 7, just 7 quarter x. That's a perpendicular line. Right, that's it. So simple. Continuing with our next problem. Yes, find the equation of the circle with center and given radius r. So what's the equation of the circle with these things? Alright, so the equation of the circle is given by, let's see. Yeah, the equation of the circle with center hk and given radius r. Yeah, I just need to do a small equation of the circle. What is it? So the equation of the circle was center hk, so we have x minus h all squared plus y minus k all squared equals r squared. So you see the center hk, the h you put here, right, and the k you put here, the opposite sign. So x minus h all squared plus y minus k all squared is equal to r squared. It's called the center radius form. Alright, CR form. What is CR form? Center radius form. Now let's see, is given radius r. So if the center is minus 5 4 and the radius is 5, remember you're always squaring the radius, so the equation will now become x minus minus 5. Remember, x, I said put opposite sign. If you have h and k, if you have minus 5 and 4, put opposite sign. So x plus 5. Why opposite sign? Because you're going to say x minus minus 5. So x plus 5 all squared plus y minus 4 all squared equals r squared. R squared is 25. 5 squared. You have to type it like this. 5 squared, which is 25. Right, solving the next problem. We have center 1 2 and radius 3, so that's easy. X minus 1 all squared plus y minus 2 all squared is equal to 3 squared is 9. Last one, x plus 2, x minus minus 2 is x plus 2 all squared plus y minus 3 all squared is equal to square root of 10 squared, 10. That's it. So you can say square root 10 squared, root 10, and if you square it, that's it, 10. Next problem, number 6. Find the center and the radius for the equation of the circle. That's quite simple because we already know what to do. Just take opposite signs and put it here, right? The center and the radius. Okay. So we are given the, so to find the center, it's going to be opposite sign, opposite sign. So center is negative 1 3, right, and the radius is square root of 64, which is 8. Next one, the center is 1 and negative 2, and the radius is square root of 9, which is 3. The center here is, there's nothing there, so 0, nothing means 0, right, and 1, and the radius is root 2. We can't simplify root 2, leave it like that. The center here is negative 2, right, opposite sign, and there's nothing by the y, so 0, and the radius is square root of 8. If you do square root of 8, you should get 2 root 2 on the calculator, because 8 is 4 times 2. Square root of 4 is 2. Right, so these are my answers. Continuing with the next problem. Right, so we are given some diagrams, so we want to find the equations of the circles, right, with using diagrams and word problem types. So this is number 7. It was the question for numbers. Find the equations of the given circles using graphs or given information. Right, so let's look at that. So we'll do A and B on the same, right, A and B in the same grid. Right, let's see. What's the center here? The center here is 1 and negative 3. Remember, that's a negative 3, that's 1, with 0 1. So I know the center is 1 and negative 3, and the radius is, let's see, what's the radius? 1 2, everywhere is the same. The radius is 2, right? So r equals 2. So the equation is x minus 1 squared plus y plus 3 squared equals r squared, which is 2 squared is 4. Let's look at the next one. The center is 0 and 3. So center is 0 3. What's the radius? Radius is, we got a big problem with the radius, because it's not passing through the right points. We need the radius. No, where's the radius? Okay, if you draw a line from here to there, that's the radius, Okay, so you need to make a triangle to solve the radius. So that's a radius. So the distance from there to there is 2, and the distance from here to there is 3. So the radius is square root 3 squared plus 2 squared, right? Which is equal to square root of 9 plus 4, which is 13. Right, so the equation will now become x squared plus y minus 3 all squared equals root 13 squared, which is 13, center radius form. Okay, because it was x minus 0 all squared plus y minus 3 all squared, y3 because that's k equals, remember, h and k. Okay, so minus the h, x minus h all squared plus y minus 3 all squared equals root 13 squared, which is 13 square root. Remember, you're always finding r squared, not r. Next question. Right, so just information provided here. It's important to know, it's important to draw a picture diagram to understand the problem much better. So if I draw a circle, right, I just remember horizontal and vertical lines are missing here. If I put a point on circle, so we've got negative 13 and negative 10, right? So negative 13 will be more towards the left, right? And negative 10, well, the center is negative 10 and negative 16. The nice thing is that it has the same y value, so it's on the same horizontal line. So perfect. So we got the center, and then this point here is negative 13 and negative 16, and this point here is negative 10 and negative 16. We got the same y value, so we can just count the distance from there to there. So the distance is from negative 13 to negative 10, which is just 3. So what's the radius? Radius is 3, so r equals 3. How did we find that? From minus 13 to 10, right? So we're going to find the equation x plus 13 squared, because that's the center, h, that's k, right? Plus y plus 16 squared equals r squared, which is 3 squared, which is 9. Remember, 3 squared, r squared is equal to 3 squared, which is equal to 9. That's how we get the 9 there. Next problem. Ends of diameter. So we have a problem here where they just gave us the ends of the diameter. Right, so we'll draw a circle, a picture diagram, and we can see everything is different here. We can see 18 is more towards 18 and negative 13 is more towards this side, right? And obviously 4 and negative 3 more will be more towards this side, so it needs 4 and negative 3, right? So this is the diameter, right? So if that's the diameter, let's find the distance of the diameter, and then if we divide it by 2, we'll get the radius. Okay, so but first we need the center, right? So we got 4 and negative 3. So how do we find the center of the circle here? We have to take the midpoint. So what's the midpoint of the what's the midpoint formula? x1 plus x2 divided by 2, and y1 plus y2 divided by 2. But remember, the midpoint is the center of the circle, so we're just going to add 4 plus 18 divided by 2, and minus 3 divided by 2. Minus 3 minus 13, this was minus 13, minus 3 minus 13 divided by 2. So we're getting center is 11, that's 22 divided by 2, and negative 8, because that's negative 3, negative 13, which is negative 16 divided by 2, which is negative 8. So we have the center. Right, now after we have the center, what's the radius? Radius is, we can use the distance formula, right? And find the diameter. Right, so what I'm finding here is diameter. This is the midpoint formula, right? So what's the diameter? Formula is x1 minus x2 squared plus y1 minus y2 squared. So using the distance formula, we have 18 minus 4 squared, right? So 18 minus 4 squared plus negative 13 plus 3. 18 minus 4, negative 13, minus 3 is plus 3 squared. So we can clearly see we are getting 100 here. So we're getting square root of, just put the entire thing on the calculator, you should get the answer. We know 18 minus 4 is 14 squared. Square root of 18 minus 4 squared plus negative 13 plus 3 squared. I've got an answer of 2 root 74. Now if the diameter is 2 root 74, what's the radius? Divided by 2. 2 root 74 divided by 2, we get the radius, which is square root of 74. So now we have a center, right? We have a center and we have a radius. So now it's easy to solve the problem. So what's the equation? X minus 11 squared plus y plus 8 squared equals square root of 74 squared, which is just 74. And that's my answer there. Right, that was a nice problem. Next one. We have a center. Okay, let's put both on one. So what did they give us here? Center is, well, this one, the last one is easy because we have center and radius already. So x minus 13 squared plus y plus 13 squared equals y plus, because opposite sign equals 4 squared, which is 16. That's it. The area is 25 pi. What's area of circle? Center is 0, 13, area is 25 pi. Area of circle is pi r squared, right, which is 25 pi. We're going to divide both sides by pi, right? R squared is equal to 25, so r is equal to square root of 25, which is 5. And remember, r is positive, r can't be a negative. That's the reason why we're not putting plus minus 25. So center is 0, so I'm saying x minus 0 all squared, so just x squared plus y minus 13 squared equals r squared. R squared is 25, or 5 squared. And the last one is done. Continuing with the next problem. Yes, determine whether the given point P lies on the circle, inside the circle, or outside the circle with the given radius and center. Right, so we want to check this problem. Right, so how do we do this problem here? First, we find the equation of the circle and then substitute the point and see if it's greater than r squared, less than r squared, or equal to r squared. So if we have the center and the radius, so the equation of the circle here is x minus 3 squared plus y minus 2 squared equals 7. Now we're going to substitute this point inside here and compare it with, so we're going to say left hand side of the equation only, right? So minus 4 minus 3 squared plus 3 minus 2 squared, right? 3 minus 2 squared, we'll get a value and compare it with 7. So that is 4950. I'm getting a value of 50. 50 is clearly greater than 7, or greater than r squared, greater than 7. So it lies outside. So what's the rule here? The rule here is if the left hand side of the equation, when you substitute the point, if it's equal to r squared, it lies on. If the left hand side after substitution is less than r squared, it lies inside, right? And if the left hand side is greater than r squared, then it lies outside the circle. Alright, so let's do part B. We said this here lies outside because it's greater than minus 4 minus 3 squared is 49 plus 1. You can work this out on the calculator. Next problem, B. Yes, to find the equation of the circle we have x plus 2 squared plus y minus 2 squared equals r squared, which is 4. Now the left hand side we are going to substitute the point x and y inside here. So we will have negative 1 plus 2 squared plus 2 minus 2 squared, right? We want an answer for this, which is 1. It's just 1, which is less than 4, so it lies inside. Let's double check this answer here. X plus 2 all squared plus y minus 2 all squared is equal to 4. That's correct. Substituting negative 1 and 2 inside here, negative 1 plus 2 squared plus 2 minus 2 squared. Yes, so 1 is less than 4, so it lies inside the circle, right? This point, the point P is inside the circle, that's what we mean, right? And the last one is we want to see what's happening with this problem here. So we have the center of the circle, right? We have a center of the circle which is 0, 1. We have a point on the circle which is 0, 5. And we have another point on the circle which is 4, 1. So let's use center 0, 1. And let's try to understand what this, where the location of these points are, right? So it makes more sense. So center is 0, 1. 0, 1. Well, let's just put that as a center, right? 0, 1. 1 on the is basically on the y-axis, right? And then 0, 5 is a point on the circle, so it's basically same x values but different y values, so you're basically just jumping 5 units up, right? So this is 0, 5, right? So what's the radius? From 1 to 5 the radius is 4, so perfect, we can find the equation of the circle. So equation of the circle is x minus 0 all squared, so x squared plus y minus 1 all squared is equal to 4 squared, which is 16. Yep, 4 squared, which is 16. Now left hand side we're going to substitute the point 4, 1 inside x and y. So 4 squared plus 1 minus 1 squared is equal to, yep, yeah, so this is working out perfect. So this is 16 is equal to 16, so it lies on the circle, so this point P4, 1 lies on the circle. So it's the point 4, 1 is somewhere around here then, 0, 1. Yeah, that point 4, this is a point P which lies on the circle. It makes sense, right? So this problem is also sorted out. Perfect. Next one. Fine. Now we are moving on to topics involving volumes and surface areas and stuff. So we want to see next problem. Are we on question number 9? Yep. Find the volumes of the two rectangular prisms below. What do you notice? Well, what we notice is that it doesn't have same volume because according to Cavalier's principle it must have the same height and same cross-sectional area. It looks like it has the same cross-sectional area but not the same height. Why not the same height? Because when we do volume formula is usually volume of A. Let's work out volume of A is area of base. This is figure 1, right? This is figure A, this is figure B. base area or cross-sectional area times perpendicular height. So cross-sectional area here is 5.2 times 11, 5.2 times 11, right, times the perpendicular height, which is 34. So if we do that on the calculator, we're taking 5.2 times 11 times 34. I'm getting an answer of 1944.8, 1944.8 units cubed. That's volume of A. Clearly the volume of B is smaller because the height is small. See, that is a slant height, which is kind of like, you know, the longest side. This is a slant height. You can clearly see this height has to be less than 34, because using Pythagoras theorem you'll definitely have this perpendicular height to be less than 34. So now clearly volume of A has to be bigger than volume of B, right? So what can we say? Give a reason for your answer. Different heights, right? And does not have same volume. Volumes are not the same. So that's what your conclusion is from this diagram. It's impossible to calculate the volume of figure B. All we know is that volume of A is bigger than volume of B because the height is shorter in volume B, in figure B. So different heights, so does not have same volume. Does not have same volume. Right, that's all we can say. It has different heights, does not have same volume. That's my conclusion. Find the volumes of the two rectangular prisms below. You can see the volumes are different. What do you notice? It has different heights. That's my notice, and give a reason for your answer. Volume A is greater than volume B because it has different heights. So you can explain yourself. Question 10. Right, so we calculating volumes and, you know, surface areas and stuff. Right, so let's look at cylinders and prisms. Find the height of the figure with volume. We already have a volume. So what is the volume of a cylinder? Volume of cylinder is pi r squared times height, because area of base is a cross-sectional area, which is a circle. Pi r squared times height. So pi, what's r squared? 9 squared. And what's the height? That's what we need to solve. And the volume is given as 4050 pi. Right, so what we can do now is we can cancel out the pi on both sides of the equation. We have 81h equals 4050. So h equals 4050 divided by 81. 4050 divided by 81 equals 50. So it is 50 centimeters. That's the height, right? What's the height? 50. You can double check your answer by taking 9. Remember, pi r squared times height. So 9 squared times 50. In other words, 81 times 50. Alright, so we're getting 4050 with a pi, of course. Moving on to the next question. Find the volume of the triangular prism. Right, so to find the volume of this figure, remember this figure has equal sides. So equal sides is the 7 there. So 7 will also be at the bottom. So this is the cross-sectional area we're looking at, right? Because the height needs to be the same throughout the figure. So there's a height 12, 12, 12, constant. So this is like you're placing the prism flat down. So this is the cross-sectional area, right? So area of base, volume equals base area times height. What's the base area? It's the area of the triangle, half base times height, half, or cross-sectional area, half, 7 times 7. And what's the height of the entire prism? The h at the end basically means the height of the prism. Whereas this is isosceles triangle, that's why it's 7, 7. So times 12. So I can say half of 12 is 6, 6 times 7 times 7. 7 times 7 is 49. Half of 12 is 6. 6 times 49 is 294 and feet cubic feet. Is it 294? Let's check. 49 times 6. Yep, 294. Next problem. Number 12. We want to find the volume of the cylinder. Easy peasy problem. Volume of cylinder, we just did one in number 12 and number 10. Volume of cylinder is pi r squared times height. In terms of pi, make sure you know how to write it in terms of pi and to decimal places, like to the nearest tenth, nearest hundredth and stuff. So volume is pi r squared times height. Pi was r squared. R is 7. Sometimes diameter is given, so you need to divide the diameter into divide by 2 to get the radius. Remember, we always need radius. Don't ever work with diameter. Pi r squared times height, which is 3. You can see the height of the right. So we have 49 times 3, so 147 pi. Now what is 147 pi? Let's check. Shift pi into 7 squared times 3. I've got 147 pi, which is 461.81. 461.81. That's inches cubed. That's inches cubed. Remember, we don't need this answer. You need to write it in this form. Right, that's my final answer. I'm just showing you, how to convert into the nearest hundredth. Was that right? Yep, 461.81. Remember, if it's 5 or more, then you round up. If it's less than 5, you ignore it. Find the volume of the rectangular prism. Easy problem, right? Just finding the volume, basics, right? Just multiplying all the 3 sides. Area of base times height, 8 times 3 times 7, alright? So volume is 8 times 3 times 7. So that's basically 24 times 7. Right, so that's 168 cm cubed, cubic centimeters. Looking at the next problem. Yes, the approximate dimensions of a swimming pool are, so I'm assuming that is a rectangular swimming pool, that because they didn't tell us. Yeah, so it's a rectangular swimming pool, 161 feet by 82 by 6.2. Even if you think about a real world application, that's what they usually have, like yeah, they usually have measurements like these, which is rectangular. So volume of the pool is basically 161 times 82 times 6.2, 6.2, no, 6.4, 6.2, and that is in cubic feet. So I'm going to write feet cubed. Let's see what's the answer. 161, right, times 82 times 161 times 6.2. So we're getting an answer of 81852.4. 81852.4. And now remember, 1 cubic feet is equal to 7.48 gallons. So we need to know about how many gallons does the pool hold. So volume of water is equal to 81852.4 times 7.48. So we need to know the amount of gallons, right? Times 7.48. So we're going to say 612,000 612,255.95 gallons approximately, because that was in 2 decimal places, or to the nearest hundredth. I put this to the nearest hundredth. Looking at number 15, surface area and volume of sphere. Now, surface area and volume of sphere. What's the surface area of a sphere and volume of a sphere? So surface area is given by surface area is equal to 4 pi r squared, which is 4 pi. What's r? Remember the diameter is 10, so radius is equal to 5. So let me just write here, r is 5, because that is d. What is given on the ball here is the diameter, right? So this is d given. So 4 pi times 5 squared, just leave your answer in terms of pi. 5 squared is 25 times 4, so the answer is 100 pi. But you need to know, as explained before, in both units of how to convert from pi to decimals using the calculator, units cubed. Sorry, this is area, so it's unit squared, square units. Now volume of a sphere is 4 over 3 pi r cubed. So you got 4 over 3 pi. R cubed is 5 cubed. 5 cubed is, let's see, 5 cubed is 125. Alright. So 125 times 4 is going to be 500. So final answer is 500 over 3 pi. You can verify this answer with your calculator, right? Units cubed. So I've got the surface area and I've got the volume. Done. Next problem. Next problem we have is question number 16. In question number 16 we have the sphere below fits inside a cube with 40 inches edges. What is the approximate volume of the space between the sphere and the cube? So the edges are 40 inches, so we need to find first the radius of this sphere. So if you try to find the radius, remember the sphere touches the top and the bottom, so the radius will be from here to there. The entire diameter is 40, so the radius will be 20. So to find the volume of the space between the sphere and the cube, find the volume of the cube first. We say 40 cubed, that is 4 times 4 times, so that should give you 64,000. Let's check it. 40 cubed to the power 3, 64,000, right? And volume of sphere will be 4 over 3 pi r cubed, which is 4 over 3 pi. R is 20 cubed, so that should give me 4 over 3 shift pi times 20 to the power 3. That will give me 33510 33510.32. And to find the volume of the space, we just need to subtract both. So subtracting both, this is going to be volume of cube minus volume of sphere. So 64,000 minus the answer that was taught before, that's going to give me 30,489.68 inches cubed. I hope you guys understand. Next one, what is the radius of a hemisphere with a volume of 144,000 pi cubic centimeters? to solve this problem. Remember, volume of sphere is 4 over 3 pi r cubed. So the volume of a hemisphere, which is half a sphere, is basically 4/3. So it becomes 2/3. 4/3 divided by 2 is 2/3. Volume of hemisphere 2 over 3 pi r cubed. And we already know that this answer is 144,000 pi. So what we can do is we can cancel out the pi on both sides. Take 144,000 and divide it by 2/3 and then take the cube root. So r is equal to cube root of 144,000 divided by 2/3 and we get our answer straight away. Shift cube root. How you put a cube root? Cube root of 144,000 divided by 2/3. Dividing by 2/3 is the same thing as saying multiplying by 3 over 2. So we get an answer of 60 centimeters. That's a radius. Next problem. A glass ball is in the box. A glass ball in the box is shown. What is the volume of foam padding needed to fill the space in the box around the sphere in terms of pi? So the reason for the foam padding is so the glass ball does not crack. So what's the volume of the cube? Volume of the cube is 3r all cubed, which is 27r cubed. And volume of the sphere is 4 over 3 pi r cubed. That's it, 4 over 3 pi r cubed. So if you take the volume of the foam in terms of r, we want the answer sphere in terms of pi, to fill the space in the box around the sphere in terms of pi. So it's going to be 27 r cubed minus 4 over 3 pi r cubed. So we can take out 1 over 3 r cubed as a common factor, right? Or you can leave your answer like this, is perfect. Make it neater. So 27 divided by 1/3 is 81. R cubed divided by r cubed cancel out. 4 over 3 divided by 1 over 3 is just 4 with a pi. So that's your answer, neater answer. So that's the volume of the foam in terms of pi. Obviously units cubed, cubic units. Because the unit of measurement is not given here, we just write cubic units for volume. Next problem. Question number 19. So what we have here is we have a plane which is cutting a cone. Alright, so it kind of makes like a cup. Now the mathematical term for a cup is basically called a frustum, right? So a plane slices a cone parallel to the base of 1/2, so it's cut in half, right, of the height of the cone. What is the volume of the frustum part of the cone lying below that plane? So remember, the total height of the cone is 10 and the height of the small cone is 5. So we can draw this thing here. So the radius over here is 5. So the radius of the smaller cone at the bottom, the piece that's cut out, is 2.5. Right. That can be proved basically using the midpoint theorem, where this line is basically parallel and half the third side. So if this bottom line is 5, the top line will be half because it's cutting through the midpoint. Right. So to calculate the volume of the frustum is volume of frustum is volume of big cone minus volume of small cone that's cut out. Volume of the big cone is 1 over 3 pi r squared times height. Remember, r squared is the first height, right? The big height, big radius and big height minus 1 over 3 pi r squared times height, which is the small radius and the small height. So 1 over 3 pi, what's r squared? R was 5 squared times 10, which is the height of the big, minus 1 over 3 pi, 2.5 squared, which is the radius of the smaller cone, times height, which is 5. So if we try to simplify this, we can take out 1 over 3 pi as a common factor. 5 squared times 10. Actually don't do this, just because we want an answer. Put the answer in both, in terms of pi and in terms of decimal value, if it's a written question. But if you leave your answer in terms of pi, that's more accurate, right? So what we have here is 1 over 3 shift pi times 5 squared times 10 minus 1 over, oops, what happened here? 1 over 3 shift pi into 5 squared into 10, right? We're getting 250 pi over 3 minus remember this is 2.5 and 5 now, 2.5 and 5, that's 125 pi over 12. So if we subtract both, 250 over 3 shift pi minus the previous answer, 875 pi over 12, which is approximately equal to press SD 229.07, 229.07 units cubed. Next problem. I hope you understand, guys. Don't forget to leave comments if you don't understand the problem. Find the volume of a square pyramid with height 11 and base edges 4. Alright, so the height is 11, and because the pyramid peaks, right, you take 1/3 area of base, 1/3 cross-sectional area times height. So volume of the pyramid is 1/3 base area times height. Right, so 1/3 base area is 4 base edges, right? 4 is a square edge. This is a square pyramid, right? Times height, which is 11, right? So we can calculate this by taking 16 times 11, 176 divided by 3. Well, we're getting 176 over 3 units cube, not units. Now the unit of measurement is given, so we write meters cubed, right? Or cubic meters. So 176 divided by 3 is also 58 point, my one is doing a recurring decimal, so 58.67. Next problem. Next problem what we have here is number 21. If the radius of this sphere is doubled, then what is the relationship? Relationship, just a typo there. What's the relationship between the old and new volumes? So, what's the initial volume of sphere? 4 over 3 pi r cubed right? So we're going to make it R naught initial volume, and final volume will be, let's call it V1, right? So final volume, okay, let's call it final volume VF. So 4 over 3 pi R final cubed. So if you take the final volume divided by the initial volume, the final volume is 4 over 3 pi. What's the final volume? It is double. If the radius is doubled, so the radius is doubled, it's going to be 2r naught squared, cube, 2r naught cubed divided by 4 over 3 pi times 2 r naught, no, times just 4 over 3 r naught cubed, yes. So what's the relationship? We can cancel out the 4 over 3, the pi and the pi. 2 cubed is 8, right? And we got r naught cubed divided by r naught cubed. R naught represents the initial radius. So we can see now that these cancel out. So what we can say is that final volume is 8 times initial volume, right? So what is the relationship between the old, you can say initial volume or old volume, right? So final volume is 8 times more than the old volume. Second one, what is the relationship between the old and new surface areas? That's of a sphere, right? Surface area of a sphere, so old surface area, so we're going to take final surface area final divided by surface area initial, old. So 4 pi r squared, right? But now because it's doubled, I'm going to write it like this, 4 pi r squared, and the bottom is just 4 pi r squared, right? Bottom is just 4 pi r squared, right? But not just r squared, r naught squared. But now this r is double, right? So we can see the 4 pi and the 4 pi cancel out, right? We have 4 r naught squared over r naught squared. You can see those cancel out. So my final answer is 4 here. So I know the final surface area is equal to 4 times more than the initial surface area. So the final surface area is 4 times more than the old surface area. Okay, so it's just a matter of finding ratios. Number 22, these are all application problems, and you know, not like really with diagrams and stuff, so you have to imagine the diagrams. Let's see, what is the largest volume a sphere can have if it is covered by 4 meter square of plastic material. You see this 4 meter square is basically the surface area of a sphere. So surface area of a sphere is 4 pi r squared. That's a formula that we have. But now using this, we need to calculate the volume. Now 4 pi r squared is already equal to 4 meter square. So we already know this is equal to 4. So now what we can say is we can divide by 4 on both sides. So we have we can divide by 4 pi on both sides. So we have r squared, or we can just cancel out. R squared is equal to 4 over 4 pi, and then r is equal to square root of 1 over pi. Remember, the 4 and the 4 cancels out because I have divided by, so remember that 4 and that 4 cancelled out, and we're taking a square root. So we will get a decimal value. Try to use more decimals. So square root of 1 over shift pi, which is 0.5642. 0.5642. That's the answer, and it needs to be positive, right? Because that's the reason why we're not putting plus minus here in the front. So volume is now equal to 4 over 3 pi r cubed. We already have the radius, so 4 over 3 pi is 0.5642. If you want, you can put this entire square root in there. You'll get more accurate answer. So we have 4 over 3 pi into 0.5642 to the power 3, to the power 3. So 0.7523 is 229, so it's 0.7523 meters cube. What if we use the entire square root as the answer instead of working in decimals? We would have square root of 1 over shift pi. We never had the same answer basically to 4 decimals. So that's a volume 0.7523. Next problem. Now in this case the volume is given, we need to calculate the surface area. So another easy problem, right? So what we have here is the drama club makes a large ball from foam to hang above the stage for display. They plan to cover the surface of the ball with metallic fabric. What is the minimum number of square meters of fabric that the club needs? So we have the volume of the sphere is 4 over 3 pi r cubed, which is given by 1.8. Alright, so first we're going to get r cubed is equal to 1.8 divided by 4 over 3 pi. You can cube root the entire thing and get the radius. 1.8 divided by 4 over 3 pi. Okay, so let's do that and get the answer. Shift cube root 1.8 divided by 4 over 3 shift pi, right? I've got an answer of 0.7546. 0.7546. One very important factor in determining surface area and volume of sphere is the most important variable there is the radius. If you don't have a radius, then you can't really calculate much. Right, so now we want to calculate the minimum number of square meters. So minimum number of square meters, they're talking about square meters, they're talking about a surface area. So surface area is equal to 4 pi r squared. So we can say 4 pi. R is 0.7546 squared. Was it 0.7546? 461, yeah. So 4 shift pi times 0.7546 squared. So we have an answer of 7.1555. 7.155, 7.16 basically. .16 meter squared. I hope you understand, guys, and we almost towards the end of the video, and we have one last question which I've just added for your benefit. Right, so let's have a look at this nice application problem. Number 24. A spherical scoop of ice cream with a diameter of 6 centimeters is in a cone 20 centimeters tall with a base diameter of 6 centimeters. If all the ice cream melts into the cone, remember the ice cream is in a spherical scoop, right? Spherical, right? If all the ice cream melts into the cone, what percent of the cone will be filled? Right, around to the nearest whole percentage. Let's see. So first we'll work out the volume of the cone, right? Volume of the cone is 1 over 3 pi r squared times height, right? Because the cone peaks, so 1/3. A volume of cylinder is pi r squared times height. Remember, you can fit 3 cones in a cylinder, 3 cone volumes in a cylinder, pi r squared times height. So we have, let's calculate the volume, 1/3 pi. What's the radius here? Remember, the diameter is 6, right? So the radius is 3, right? And the height of the cone is 20 times 20. So we will get an answer here, which is 1/3 shift pi times 3 squared times 20. I've got a nice answer, 60 pi, right? Leave your answer like this, 60 pi. You may round off if you want. And volume of sphere, right, is 4/3 pi r cubed. So we have 4/3 pi. What's r? R is 3 cubed. 1 3 1 3 cancel out. I think you'll get 36 pi. Let's just double check that out. So we have 4/3 shift pi times 3 to the power 3, 36 pi, right? So now if you want to calculate the percentage that will percentage of the ice cream that will melt into the cone or occupy the space of the of the cone, you say percentage is equal to 36 pi, right, divided by 60 pi times 100, and that will give us the percentage. So we can cancel out the pi, so you can just say 36 divided by 60, right, times 100. So that's giving me 60%. So if you just say if you had some decimal values and stuff, you still have to round off, just because the way this question was structured, they didn't have decimal values. That's why it said round to the nearest whole percentage. Alright, so that's the answer, 60%. Right, it's been a long video, guys. I hope you understand. If you don't understand anything, don't forget to comment on the sections, and also if you're having any problem, just clear it out, right, in the comment section, or email me as well. Thank you, and enjoy your day, and good luck for the final examination. All the best.